Okay folks, welcome to lecture 17, which is going to be the last lecture in module 1 of my video series on introduction to data structures in C. Okay, let's get through some demo programs for today. The first program given out here is that write a C code to count the number of vowels and consonants in a given string. Okay, so the user basically needs to input a string, and based on the input given, the program should count the number of vowels and consonants present in the string. Okay, so that's the task given. Before going through the code, I would just like to highlight that string is nothing but a character array which starts from index 0 to some value based on the length of the string given by the user. And after entering the string, the user basically enters an enter key, okay, which gets terminated as a null character or termination of the string. So every string has a null character or a terminator at the end to demarcate the end of the string. Okay, so take that into account. First point, string is nothing but a character array with indices, and the other one is every string is ended with a null character as its terminating point for that string. Okay, so with this knowledge, let's actually look into the C program which does this. Okay, so in the main code I have allocated a character array which can read up to 50 characters. So that would be the upper limit of the string that you can type in. So your input can have a maximum of say 50 characters. Then I have a char pointer or a character pointer. Then two integer variables are being defined, the control V and control C, one to count the number of vowels and the other one to count the number of say consonants. Okay, then a message is printed out asking the user to print input the string. Okay, so this message gives out the what do you say what the code does, okay, the functionality of the code. Okay, so not mandatory, it's there. Okay, and then this line basically asks the user to input the string. So having given these messages, the string is being read using the fgets function. So this, look at the format of the fget. We had talked about this in my previous lecture. So the first parameter is the place where you want to store the string. Next gives the upper bound, that is the number of values that can be read in. Okay, out here it is the length of or the size of str1, which is 50. So fgetS limits itself to the first 50 characters that is being typed in from the standard input device. Okay, so the place where you need to store the string, how many characters needs to be read, and from where they need to be read. In this particular case, I am reading it from the standard input, which is the keyboard. So this line of code basically serves as an alternate to scanf. Okay, so fgets basically reads the string including the spaces. Okay, using scanf we knew that we cannot read spaces. Okay, so that was the drawback using the scanf function to read string. So if you are reading string, fgetS would be the best possible way to do it. I strongly recommend fgetS. I use it all the time. Okay, so having read the string into this character array, okay, the pointer out here, the base address of the array is being passed to the pointer. So the pointer basically points to the first character of this array. Okay, so that is what happens out here. Having done that, I initialize the counter variables of the vowels and consonants to be 0. Fine. So all set, and let's get into the loop of reading each character and deciding whether it is a vowel or a consonant. So till you reach the end of the string, which is been indicated by this line termination or null character. So I say till the pointer is pointing to the null character. Right now the pointer is pointing to the first element of the string. So till the pointer points to the null character, keep on looping into. Okay, so that is what this line says of the while loop. So it is a conditional looping. Okay, so having done this, I see whether the pointer which is pointing right now is pointing to any one of the ovals, including the uppercase and the lowercase. So whether pointer is a capital A, or you remember the logical OR operator. Okay, so or is the pointer pointing to a E, or is it pointing to a I, or is it pointing to a O, U, and similarly for the lowercase. So if the pointer is not pointing to any of these, then obviously it is not a oval, so you can skip out this line. And if it is pointing to any one of this, if the character out here to which the pointer is pointing to is any one of this, then obviously it is a oval. Okay, so if this condition is true, increment the oval part. If it is not, increment the consonant part. So that is what is this line of, or this while loop does. Okay, so having decided on whether the given pointer, whether the given character pointed by the pointer is either a oval or a consonant, I basically increment the oval counter or the consonant counter. So having done this, okay, then I increment my pointer to point to the next variable. Okay, so this is the body of the if else, and this is the body of the while loop. So I have not yet come out of the while loop. Okay, so this is the if else loop, and I go to the next line of the while loop in which the pointer gets incremented, so it points to the next character. So again I come back and see whether the next character is a null character or a line termination. If it is not, repeat the same process till the pointer reaches the null character, which indicates the end of the string. So at that point of time you come out of this for loop. Okay, so that is what happens out there. Okay, so once you come out of the for loop, what is there in control V or counter V and counter C is the number of ovals and consonants which are present in that particular given string, okay, or character array. So then I print out what is the number of strings and ovals which are available or present in that character array, okay, and then come out of it. Mind you, this is -1 because I need to basically remove the end character as well. Okay, so that's why this -1 is there. Okay, so hope you have got this concept. Okay, now let's go to the next task. The next task is to basically see how pointers can be used to for structures as well. So we have used pointers with arrays. Okay, a character array or integer array, both will be one and the same. Okay, but can we use pointers to point at user defined data types such as structures? They can be. As I said, pointers can basically point to anything. They can point to primitive data types, user defined data types, okay, and they can be used to point to functions as well, but that's for some other day. Okay, so today we'll see how the pointers can be used to point to user defined data type. In this case it is a structure. So in this code snippet which is been given, a structure is first defined. Okay, a structure called employee address is defined, and what does the structure hold? You remember, structures are used to basically stack different types of data together. So here I have a character pointer as one of the members of the structure. Then I have a character array whose length is 20 and the name of the array is stname, and then I have an integer variable which can store the pin code. Okay, so that's the content or the definition of the structure. So having defined the structure, I instantiate a structure, or I create an instance of this structure, and the name of the instance or the variable structure variable which is created is called as employee. Okay, so that this is the instant of that particular structure. Okay, so normally the variables created from a user defined data types are termed as objects. Okay, so this is an object created out of this structure. That would be the standard terminology that you would be hearing more often, but people do also refer to them as instances or variable of a user defined structure. Basically they are all the same, doesn't matter what terminology that you use to refer to it, as long as you know what it is. Okay, so I prefer the terminology instance as far as C goes. Okay, so I normally use it as an object or an instance, both are one and the same. Okay, so here is an instance created out of the employee structure, and the instance is been basically initialized as well. So the character pointer basically points to the string literal. Okay, these are all literals. Okay, so this character pointer points to the string literal. This character array stores this string literal. These are two different things. Okay, this array stores it, this pointer points to this literal. Okay, so this array st name stores this string literal. Okay, with the next line as well, and this pin code associated with the employee stores this literal, which is an integer. Okay, so an instance is being created, it is being initialized with proper values, and then again a pointer of this type is being defined. Okay, so what is pt star pt? Star pt is a pointer which can basically point to any instance which are created out of this particular user defined data type, that is employee address, and I've already created an object of this particular data type, which is the employee. So the address of employee is now been passed to this pointer. So pointer points to this particular instance or object, and it is both are global. Okay, as they are outside the main function, they fall into the global scope. So that is what happens in these lines. So having talked about this, let's look into the main code. Okay, so in the main function, basically a message is pointed out saying that this shows how a pointer to the structure can be used. So the structure is being defined, object is being created, a pointer is defined, and which points to the created object. Okay, so how do I access members of this object using pointers? Okay, so you can point to the members of this object using the name of the object employee, as well as you can use the star pt which points to that object. So how do I use that? Okay, this line of code illustrates how you can use it. If you want to address or if you want to access any one of these members using the pointer, then the notation that is used is the arrow point. So pt arrow ename points to this literal John alert. Okay, the same thing can be if you want to point to the character or any other name, the same thing can be replicated as this. So the compiler basically takes this and converts it into that. Okay, so either you can use arrow symbol, or else you can use the dereferencing operator as well, or the referencing operator. You can say star pt dot stname. Here you could have told star pt dot ename. Okay, here you can use star pt dot stname. So this prints out code string. Okay, so this print out John alert, John alters. Okay, so this prints out John alter, and this prints out code string. Okay, so you can use a pointer to point to an object provided that it is pointing to it. You can access the members of that object provided that it is pointing to it, either by using an arrow operator or by using a dot operator as well. Okay, so both are permissible, and you can use a pointer to point to the members of an object created from a structure. Okay, so that's the takeaway from this exercise. Okay, now let's get into the next program. Out here I want you to count the total number of alphabets and digits and special characters in a given string. In the previous program we had seen how to calculate ovals and consonants. Here I assume that this string has digits and special characters apart from ovals and consonants. Okay, and I want to segregate them as alphabets, or whether it is a given digit or is it a special character. Okay, whether a string, how many alphabets are there, how many digits are there, and how many special characters are there. So I want to count them in a given string. So that's the task. So let's go get into the program how to do that. So out here I have defined a macro to say what would be the maximum size of the string, and then I have my string library and my standard library defined out there. So then I define a character array of this maximum value. A couple of variables are also been defined. Okay, and then they are set to 0 or initialized to 0, and then I use my fget function to basically read the string, okay, into the character array. Having done that, I again, like my previous code, I iterate through the character array till I hit a null character or string termination. So till then I keep reiterating it through this. Okay, earlier I had used a pointer, here I am using a array. Fine. So till I is equal to 0, presently I is pointing at the first element of the array. Okay, so if the first element is not a null termination, which means to say that there are some elements in the string, keep on iterating. So see if the first ASCII value of the first number is from A to Z, or is it from capital A to capital Z. Mind you, each one of the character information is stored in the ASCII value. So when you compare like this, the value ASCII value which is stored gets compared to the ASCII value of the character A. Okay, so you basically see, is the first character lying between capital A to capital Z, or capital A, small a to small z. So if the ASCII value stored here is in this range or in this range, then obviously it is a character. So it is an alphabet. Okay, so increment the alphabet. If it is not, check if it is a number, whether the character is from 0 to 9, that is the ASCII value stored in the character array is between a character 9 and a character 0. If it is, increment the digit. If either of them are not true, then obviously it is a special character, so increment that. Okay, having done that, increment the pointer or the index of the array I, because while loop doesn't do that on its own. Like a for loop, you need to do it explicitly. Okay, so an explicit increment in the index is done, and you keep on looping that till you hit the string termination. Okay, so till you hit the string termination, see whether the value in that particular index is between capital A to capital Z or small a to small z. If it is either of them, then the given character is an alphabet. If it is not, check whether it is from 0 to 9. If it is from 0 to 9, it's a digit, and if either of them are false, then obviously it is a special character. So keep on doing that in that loop. So once you come out of the loop, as when you come across the string termination, then in these counters you will be basically having the total number of alphabets, digits and special characters which are there in that particular string. So you print them out, okay, using the printf command. Hope that you have got this logic of this program. Okay. Now we will see how to convert a decimal number to a binary form using a function. Okay. So given here is a piece of code which accomplishes this task. Okay. So here I have a main function and then I have a user defined function. The name of the user defined function is toBin. And what does it take? It takes in an integer, and what does it return? It returns a long integer. Okay. So that is been defined out here. So the function definition, in the function definition part, okay, I define this, I declare this function, sorry, function declaration part, not definition, declaration part. Okay, and the function definition part has the definition of the function. Okay, so here I have the declaration of the function. So I have function called as toBin, which takes in an integer and returns a long integer. And then I have my main function. So the main function basically reads a number, okay, and stores stores its equivalent. So those two values or variables are being defined out there. Okay, one to store the number in the binary form and one to store it in its decimal form. Okay, so that is what bnum and dnum is for. Then I read the number in its decimal form and store it in dnum. Having stored the number in dnum, I pass on this dnum to my toBin function, which I expect to return the binary number. So I get the binary number from this function, store it into bnum and then print the value of bnum. So that is what happens in the main function. Okay, having done that, I terminate the main function. Okay, so now having written the main function and defined what is the toBin function and its functionality, now it is time to basically define it. Okay, having declared it, now it is time to define it, that is to actually code the functionality of this toBin. Okay, so as per the declaration, I have long as the return type and integer as the input for this particular function or one of the variables or parameters of this function. So one of the input parameters is int and then I have dnum as the input. Mind you, this dnum is local to this function, this dnum is local to this function. So these are two different things. What gets passed into this dnum is the value of this dnum, so that gets this value. Okay, but they are two different things. That's why I given a different color code out there. Okay, once the value of dnum is been established or passed from the main function, then I initialize the bnum, which is local out here. This bnum is different from this bnum. Okay, so that is been initialized to 0. Then I have a remainder value variable to store the remainder and to store the f. Okay, that is the fractional part. I initialize it to 1. Okay, and then I iterate through dnum till it is not equal to 0. Okay, so in the remainder part I take dnum mod 2. Okay, so the value of mod 2 of dnum is being taken into the remainder, and this remainder basically what does it do? Okay, so when you take mod 2, what is the remainder? It is either 0 or 1. Okay, depending on what is the value of dnum. So basically based on the value of dnum mod 2 will give me either a 0 or a 1. It will, if dnum is odd, it will give me a 1. If dnum is even, it will give me a 0. So that is how binary to decimal to binary conversion is done. So having got this value, now I start stacking it. Okay, so I put either a 0 or a 1 there, I multiply it with 1. So doesn't matter whether it is a 1 or a 0, it gets out there. Then what I do to f, I do f is equal to f into 10, because the next value needs to be stored in this location. Okay, so then I do d naught is equal to d naught by 2. So basically you divide it by 2 and get the next value. Okay, and then you start repeating the same over and over again. Okay, so the next value, which is 0 or 1, is stored out here. Then f get multiplied by f into 10, which is becomes an 100. So then you get a 1 or 0 out there, which gets stored out in the next in the 100th position, and so on. Okay, so at the end of it you will be having bnum as a number which consists of zeros and ones. Okay, a 32 byte number, because it is a long, sorry, not a 32 byte, it's a 8 byte. Okay, long is for 8 byte. So you get a long is 8 byte number. Okay, so 8 into 1 byte is 4 bits, 8 bits, so 8 into 8, so 64, so 64 bits. Okay, but 8 bytes. Okay, so you get that in dnum, bnum, because that is what it is long, and then you return the value of bnum, which gets printed out there. Okay, so that is how you convert a given binary number to a decimal number. Okay, using an external function. Okay, hope that this clears the concept of how to convert a decimal to a binary using a C code. Okay, so that's all for today, folks, and thank you for staying with me for this module 1. So in my next lecture we'll start with module 2, and we'll get to know about what are algorithms and how to basically formulate them in terms of their asymptotic notation. We'll also talk about dynamic memory allocations and how arrays can be dynamically allocated and can be accessed in the heap rather than in the stack. We'll talk about stack, heap, and dynamic memory allocations with respect to arrays, and then we'll talk about algorithms and basically how to quantify them in terms of some asymptotic notation. So that is in store for you in module 2. So hope you have enjoyed lectures on module 1, and stay tuned for this series. Thank you.